Welcome to this video. My name is Tracy Khan, and today I shall be presenting my solutions to the supplementary assessment. To begin with, question 1, linear algebra. A manufacturer produces books at a daily cost of 80 cents per book and sells them for $1 per item. The daily operational overhead is 400. What is the break-even point? So here we can note down that the daily cost that the company incurs is 80 cents and it sells the book for $1 per book, or you can say per item. And daily operational overhead is 400. Solution. Here we are to use the cost is equals to revenue equation. So our cost from the question itself would be 80 cents x plus 400 is equals to $1 x. Now, to solve for this equation, we'd have to take the 80 cents to the other side. So when we do that, 80 cents gets cancelled out on the left-hand side of the equation. So $1 minus 80 cents is simply 20 cents x. Now, to solve for x, we need to take 20 cents to the other side. So 400 divided by 20 cents would give us a x of $2,000. Therefore, we are going to substitute 2,000 in place of x. By doing so, we will get a value of 1,600 plus 400 on the left-hand side of the equation, which gives us 2,000, and $1 into 2,000 is simply 2,000. So we can note now that the break-even point for this question is $2,000, as the right-hand side of the equation and left-hand side of the equation are both equal. Next up, question 2, linear interpolation. Use linear interpolation to approximate the value of I from the following equation. Here we have the equation. It is 1 plus I to the power of 16 minus 1 divided by I is equals to 18.1818. Here I've drawn a table where the first column is interest rates in percentage-wise, second column is interest rates in decimal place, and the third column is where I have the equation and where each interest rates are substituted in place of I to give us the following values. Here we are looking for, I have guessed a few values that I was familiar with. So I started off with 5%. I substituted in place of I, and I got the value 23.657. This value I will not be using, as it's not the value that I intend to look for. Here I'm trying to look for a value that gives me below 18.1818 and a value that is above 18.1818. So we can see, right, 1.15% gives us that value. If we substitute 0.015 in place of I into the equation, it gives us 17.93236. Now this value is what we're looking for, as it's below 18.1818. And we have 1.6%, which is 0.016, substituted in place of I, which gives us 18.071109. This value is what I intend to take, as it's above 18.1818. So then we use the following values, right, to estimate the value of I. So here in this instance, x1 will be 0.015, y1 will be the value substituted from 0.015 in place of I in the equation, and I is simply unknown, that's what we are looking for, and x we do not know yet because that's what we're looking for, and y is given in the question itself, which is 18.1818. The last one is 1.6%. This is our x2, which is equals to 0.016, and y2, which is 18.0711. This value is got from substituting 0.016 in place of I into the equation. Therefore, we have this equation in front of us, right? Y is equals to y1 plus y2 minus y1 divided by x2 minus x1. times x minus x1. From the previous slide, I have showed that y is equals to 18.1818. Therefore, y1, which is 17.9324, plus y2, 18.0711, minus 17.9324, which is y1, divided by x2, which was the interest rates, right? 0.016 minus x1, 0.015, times x, which we are looking for, minus 0.015, which is x1. So when we compute the following, 18.1818 minus 17.9324, 17.9324 was taken to the other side. When taken to the other side, we minus it off, and then that gives us a 0.2494. When we computed the following subtraction from the brackets, we got 138.7 multiplied by x minus 0.015. Therefore, 0.2494, in order to solve for x, we take 138.7 to the other side. Therefore, 0.2494 divided by 1387 is equals to x minus 0.015. Now, in order to solve for x, we need to plus the 0.015 towards the left hand of the equation. Therefore, if we do so, x is equals to 0.01679812425. If we round that off, that gives us 0.01679. Therefore, I is equal to, in percentage wise, it would be 1.68%. Now we have to check and verify the answer. So if we substitute the value in place of I, it would give us a 18.1830431, which is equal to 18.1818 if we have to round it off to 2 decimal points. Next, question 3, basic calculus. The selling price of a particular type of car is 20,000. The total cost of producing the car is total cost is equal to 2,000 plus x squared. Part A is to find the marginal revenue function, part B is to find the marginal cost function, and part C is to find the quantity that maximizes profit. So let's get into it. Part A, marginal revenue function is the first derivative of the revenue function. In turn, the revenue function is simply equal to P of x times x, which is simply price function times quantity. Note, P of x is equal to 20,000. Thus, R of x is equal to P of x times x. Thus, R of x is equal to 20,000x. When differentiated, it gives us simply 20,000 as x cancels out. Part B, similarly, marginal cost function is the first derivative of the total cost function. Thus, C of x is equal to 2,000 plus x squared. This equation, right, this equation was given in the question itself. If we were to differentiate it, it would simply be 2x. As 2,000 is a constant, it would cancel out, and x to the power of 2 is simply 2x to the power of 1. Part C. Find the quantity that maximizes profit. Marginal profit, in this case, marginal profit must be set to equal to 0. Right? So therefore, the differentiated equation would be P of x is equal to R of x minus C of x. Thus, R of x minus C of x would be 20,000 is equal to 2x. X is equal to 20,000 divided by 2, right? So x in this case is equals to 10,000. We can say that 10,000 number of cars produced is the quantity that would maximize profit for this company. Thus, since the maximum profit is at point x is equal to 10,000, P of x is equal to R of x minus C of x, right? That gives us 20,000 x minus 2,000 plus x to the power of 2. P of 10,000 is simply equal to 20,000 multiplied by 10,000 minus 2,000 plus 10,000 to the power of 2. Therefore, 200 million minus 2,000 minus 100 million is equal to $99,998,000. Question 4. Progressions. A woman borrows $1,500, agreeing to pay $100 at the end of each month to reduce the outstanding principal and agreeing to pay the interest due on any unpaid balance at the rate of 12% per annum. Therefore, there's about 12 months in a year, so 1% per month. Determine the sum of all interest payments. There's a few information that we can note, right? The borrowed amount is $1,500, agreeing to pay $100, which is 1% of every month, $100 at each month. Monthly principal payment flows would be reduced as follows. 1,500, so there's a difference of $100 in each flow. Therefore, the interest rate would be 15, 14, 13, up to 1. N is equals to 15, T1 is equals to 15, and Tn is equals to 1. Total interest would be, by using this formula, we can find the total sum of payments. Therefore, S of n is equals to 15, so because n is given as 15 divided by 2 times 15 plus 1. That simply gives us 120 as the sum of all interest payment. Right? Therefore, sum of 15 monthly interest payments is $120. Question 5. Linear programming. From the question itself, a couple has to invest up to $30,000, right? And we are given two bonds, right? AAA bond at 8% and B plus bond at 12%. B plus bond has to invest at most $12,000, right? And AAA bond should be at least $6,000, right? Amount invested in AAA bond should exceed or equal to the amount invested in B plus bond. Solutions. Here in this case, we let X be the amount invested in AAA bond and let Y be the amount invested in B plus bond. Here the defined return would be R is equals to, so R stands for return, is equals to 0.08x plus 0.12y. Steps to consider. Step 1, we are to identify the objective. The objective is to find the maximum return, right, for the couple. Step 2 is to list the objective function, right? So here is simply this equation, which is return is equal to 0.08x plus 0.12y. Step 3 is to identify the constraints. Up to 30,000 to invest would be equal to x plus y is less than equal to 30,000. Invest at most 12,000 in B plus bond is equal to y is less than equal to 12,000. And at least 6,000 in AAA bond would be equal to x is greater than equal to 6,000. Amount invested in AAA bond to exceed or equal to the amount invested in B plus bond. So x is greater than equal to y. Right. Therefore, our following constraints is x plus y is less than equal to 30,000, y is less than equal to 12,000, x is greater than equal to 6,000, x is greater than equal to y, x is greater than equal to 0, and y is greater than equal to 0. Therefore, x, that means that the bond should be less than equal to 30,000. And for this one, it should be that it's less than equal to 12,000, right? And more than greater than is equals should be 6,000, right? So therefore, step 4 is to graph the constraints. So in this step, I have drawn my graph, right? And in this graph, I have points labeled A, B, C, D, and E. And I have graphed the following constraints that we have identified. In this case, to solve for the first constraint, x plus y is less than or equal to 30,000, we go x-intercept y is equal to 0. So x plus 0 is equal to 30,000. So x is equal to 30,000. So our first point would be 30,000 and 0, right? Which we have plotted, right? X is, right? So 30,000 and 0, right? Here we have it. Sorry, here we have it. And next would be y-intercept, x is equal to 0. So 0 plus y is equal to 30,000. Y is simply equal to 30,000. So 0 and 30,000. So 0 and 30,000. So that's this line going right over here, right? Then we have y is greater than or equal to 12,000, right? So we have 12,000 and 12,000. So that is this line over here. So 12,000, right? X and 12,000 over here, right? So we have one line going this way, right, in red. And then we have x is greater than or equal to 6,000, which is simply 6,000 and 6,000. So we have that line over here marked in black, right? And then we have x is greater than or equal to y, which is this purple line, right, going this way, right? Now we can see that this is the area, like highlighted in orange, where all the lines, they intersect each other. That point or that particular area is called the feasible region. Now from this area is where we have to figure out our points A, right? So here we have, right here, the first point would be A. So A would be given as 0, right? Sorry, 6,000 and 0. B would be 6,000 and 6,000. Here C would be 12,000 and 12,000. Point D would be a 12,000 and 18,000 and 12,000. And point E would be a 30,000 and 0, right? So I've created this table, right? So point A, you have 6,000 and 0, point B, 6,000, 6,000, point C, 12,000, 12,000, point D, 18,000, 12,000, and point E, 30,000, 0. These corner points are what we are going to use to substitute it in our objective function. Therefore, if we are to look at the first one, right, we have 6,000 and 0. So in place of x, we put 6,000, and in place of y, we put 0. Once we, compute this, it gives us 480, right? This is our return. Then we look at the next one, 6,000, 6,000, right? So in place of x, we put 6,000. In place of y, we put 6,000. When we compute this, it gives us 1,200. Point C, in place of x, we put 12,000. In place of y, we put 12,000. When we compute this, it gives us 2,400. Okay, if we look at point D, when we put x, when we put 18,000 in place of x and 12,000 in place of y, and we compute this, it gives us $2,880, right? And E is 30,000 and 0. In place of x, we put 30,000, and in place of y, we put 0. It gives us 2,400. Now from this table, we have to figure out the maximum return, right? Remember that we as a broker, if we are recommending to the couple to, we need to recommend a point that maximizes the return. So we are going to find the highest return figure, which is what I've highlighted in yellow, which is at point D, where we have x at 18,000 and y at 12,000. That gives us 2,880. This is the point, right, where the couple can maximize their return. Step 5, conclusion. To conclude, the couple should invest by placing 18,000 in AAA bond and 12,000 in B+ bond, as the maximum occurs at point D, where the maximum return the couple would receive is $2,880. With that being said, I'd like to conclude this presentation as well. Thank you.